Okay, so welcome everybody. My name is Mark Paluch. I'm working with Pivotal. I'm part of the Spring team. God bless you. And I'm here today to present you the topic of reactive relational database connectivity. That's heavy Java oriented. So you might probably know there's a thing going on. So basically, there are always lots of things going on in IT. But this particular thing I'm going to talk about today is reactive programming. So we see reactive programming to be the next frontier for Java development. We get a lot of scalability of reactive programming patterns. We get very highly efficient systems when we build software using reactive programming paradigms. And this is because we invert the idea of today's programming model, how we do today imperative programming, where we are responsible and in charge of managing resources, things like threads, connections. And reactive programming basically turns the entire idea upside down, where we declare what we want to do, and then we give this piece of work and this declaration, how we want to execute something, to our platform, which then takes care of a very efficient usage pattern. And it makes sure that it does not block threads. So that's one of the most challenging parts, to not block threads. And threads are limited resources, similar to CPU count and RAM. So every time we spin up a new thread, we allocate memory and we consume a bit of CPU power. And reactive systems say we have as many threads as CPU cores in our systems. So we basically ban away blocking. So the general idea of reactive isn't really about concurrency or asynchronicity. In fact, reactive programming has no opinion on whether something is asynchronous or concurrent, but it has an opinion on not blocking things. So that's the core idea we have there. Another thing, what we often see in reactive programming, is that paradigm shift in terms of flow control. So today, when we deal with data or even records, we tend to think in lists, in for loops, and these kind of things. That's flow control in an imperative way. And a reactive system entirely reconsiders how we think about this flow control. It takes away from us the need to iterate over data, but rather we see each data item individually. So we get rid basically of that list. We get rid of this for loop or while loop that we use to transform data from one representation to another. And to do so, the reactive systems have introduced a concept of pull, push, back pressure to make sure that we only process as many data as we have capacity for, and to not overwhelm any slow consumer with a fast data source. So if we today try to express our programs in a reactive way, then we will see that there are already a lot of integrations available. So I brought an example with me from Spring Web Flux. And what this basically does is it tells, hey, go to my Alpha service, fetch there some health check, go to the Bravo service, fetch over there also the health check, and then once all these results are available, build a composed health check out of that. We do not execute that code immediately, but rather we create a recipe how to do things. And in that example, it is 2 HTTP requests. Then we zip that result together. And also, this zipping is just a recipe. And as soon as the data is available and provided by the implementation, then we compose data from both data sources and return a composite health. So that's basically how we tend to think in reactive systems about that. However, if we try to go reactive everywhere, we will encounter a couple of roadblocks. So reactive programming is still a young thing, and we aren't able to provide and come up with integrations for each of the systems that we would like to integrate with. So, for instance, when we have a reactive written unit, then this is typically one single process. With the outside world, we communicate with Kafka, with HTTP, with various other protocols. So we lose that notion of backpressure at our process boundary. And we cannot communicate this backpressure information from one process to another. That's a thing that is going to be worked on under the name RSocket, which stands for Reactive Socket. And this protocol basically encapsulates the backpressure information. So if I'm interested in one item in one process, then I can also communicate this information to another process so that the other side does not do more work than it is really necessary to do so. Another thing which often comes up in that context is persistence, data access. We have already a couple of integrations with NoSQL stores because they scale really well. They are also very vendor-specific. So a MongoDB is able to come up with its own driver, like a Cassandra or a Redis. But the reality is, most of our data has its home in a relational, in a SQL database. And for SQL databases, we have one standard on the JVM, which is JDBC. But the thing with JDBC itself is, it is a blocking API. It uses input-output streams. It uses blocking connections, blocking sockets. And this is something which does not cope with Reactive at all. So that's why we are going to talk about R2DBC. And R2DBC is a specification designed from ground up to cater with reactive programming paradigms. It is fully non-blocking, and it is basically a specification to abstract away just the wire protocol of the database. And the funny thing about R2DBC is how it was really born. So once in a year, we as a Spring team have a Spring One conference where everybody from the Spring team meets. And back then, 2 years ago, we were all discussing, what do we do about data access? And then somebody came up with this crazy idea, hey, let's do an experiment. Let's see what we can do about that. And that's basically how it started, from a simple idea to an implementation for Postgres, and then it evolved towards a specification. So what are the dependencies of R2DBC? And this is surprisingly, well, almost nothing. So we need, as a dependency for R2DBC, only Java 8 and reactive streams. And if we observe that from a Java 9 perspective, reactive streams has wandered with Java 9 into the JDK itself. So basically, when moving that specification forward to Java 9 and newer JVMs, then we are basically dependency-free. And that's, I think, something which is great to achieve because we aren't really relying on vendors or specific libraries. We established a few design principles within the R2DBC ecosystem itself. And we are embracing reactive properties. We're end-to-end non-blocking. Every time we start a conversation with a database to execute a statement, to begin a transaction, to commit a transaction, we communicate through non-blocking facilities. And those who are already familiar with reactive streams know probably the type publisher. And that's a handle that allows us to communicate that I want to start something in a non-blocking way and to receive a synchronization or even results in a non-blocking way. And that's what we are using all the way down. So executing a statement is a publisher. Connecting to the database returns you a publisher that allows synchronizing. So we have not only created this SPI around R2DBC, which declares and abstracts the wire protocol itself, but we have also written documentation for the specification, a prose that explains how this specification is supposed to do and what it stands for and things that it doesn't implement. The driver SPI itself was really shrunk to a minimum. And this is to cater just one purpose. So just for me, how many of you are Java developers? Oh, cool. Who of you like working with JDBC? Yeah, I felt that. So don't get me wrong, JDBC is an awesome thing because it's mature. We have lots of drivers, lots of integration for JDBC. But the thing with JDBC is, well, it's catering two purposes. On one hand, it abstracts away how we communicate with the database. It declares a statement, prepared statement, callable statement, these kind of things. On the other hand, JDBC was designed in mind with application developers. So they should be able to use that API. And so we have a duality here that on the one hand, we have to come up with something that is usable by users or application developers and implementable by driver vendors. And what JDBC is basically doing is it's duplicating a lot of features which every driver developer has to implement and then come up with an API that only very little people are happy to use it. So our goal with our TwoDBC SPI is to cater only a single purpose, to provide an SPI that is good to implement for driver developers, but it is not intended for application developers. In fact, it is intended for library authors, for authors that want to build on top of our TwoDBC, a library that makes our lives as application developers easier and much more productive, and a library that allows us to cater for our use cases, like portability or ease of use. So there are various use cases and various ways how we can use the data access itself. So one thing, but actually two things that are duplicate effort for every driver developer is this abstraction over parameters. Every database itself has native bind marker types. And these types are used everywhere except for Java. So you can, when you use SQL Server in PHP, then you see this @notated parameters. When you use SQL Server in Go, you see that same. If you use SQL Server on Java, you see question marks. So every driver developer has to build an abstraction around that to translate and parse SQL and translate it to the driver native format. That's one thing. Another thing, which is also commonly implemented across various JDBC drivers, is URL parsing. And there, really, we do not have any standard at all. Everything begins with JDBC double column, but the rest of the string is up to the driver maintainer itself. One driver uses URL syntax, the other one uses some other fancy syntax. But the common thing here is every driver developer has to implement that URL parsing part. And really, that's no fun for all. So we are taking these learnings to come up with a modern SPI. And now let me walk you through the API we have crafted so far. So it all starts with a connection factory. And a connection factory is basically the first thing you see when you are dealing with an R2DBC driver. It is able to provide you with a connection, basically. But that's not all. A connection factory can also be a decorated thing. So just think like it may be a connection pool. It may be implemented by some wrapper that wraps your driver to give you insights or metrics. So the connection factory is a general thing. And once you ask for connection creation, the driver or the thing below that is going to the database or to its connection pool, produce a connection, and as soon as the connection is ready for use, it is going to emit that connection as a result of the publisher subscription. There's also a little bit of metadata, but who cares about metadata? So once we get a connection in our hands, we will see a lot of methods which are mostly related to transaction management, like begin transaction, create save point, release save point, rollbacks, isolation levels, these kind of things. But really, the most interesting pieces for us are the statement creation or the batch creation. And batch is basically a collection of statements. So let's take a look on the statement itself. The statement accepts a SQL string, and the driver itself figures out whether that's a parameterized SQL or whether that's not parameterized. It's not really important for any user to know that distinction, because honestly, if that thing which we pass in is not parameterized, we typically do not call bind methods, right? But rather we just execute it right away. On the other hand, if we use parameterized statements, then we typically call bind methods, and the driver has to figure out the best mode and the best way how to execute a statement. And SQL Server itself has at least 4 methods to execute a statement, with cursors, without cursors, direct mode, prepared mode, RPC mode. Postgres has at least 2, and I think there are lots of other databases that have even more modes how they execute a SQL statement, depending on how the statement is built, how we want to consume results, whether we want to use cursors or not. But that's really not something that should bother us as users of that SPI, but rather the driver is able to figure that out in the most efficient way. Now, when we create that statement, we are able to either execute it immediately, right away, if there are no bindings. And if there are parameter bindings, then we bind parameters to that statement and can execute it then, or even go into batching mode so that we bind multiple sets of parameters. So I want to execute a statement with parameter 1 and then execute the same statement with parameter 2. And that's a thing where a driver could make use of prepared statements. And again, that's something up to the driver and not something that should really bother us. We can even indicate that we want to return generated values in a more or less controllable way. Retrieving generated values with JDBC is meh, it mostly works. So once we execute that statement, we get a result in our head. And the result allows currently consumption of the affected rows count. So if I'm executing an insert, update, or delete, that's maybe something I'm interested in. If I'm executing a SQL statement for select, then I'm most likely interested in the tabular rows consumption. So I hand in a by function, which accepts a row and row metadata, which tells me which columns I have, which types I have. And then I'm able to extract data out of that and return it as a publisher. And all this happens in a deferred way. So as soon as the first row arrives in my driver, I'm already able to process that row, and I do not have to wait until all the data has arrived finally on my machine to start processing. And I think that's the strength of that API here. And the lower part basically shows what we have on a row. We have a get method with an identifier that can be either that index of a row, or it can be a name of index of a column, or the name of the column. And optionally, it takes a type, so the driver can make typecasting and conversion operations for us. That's all cool, but let's see it in action, how it basically would look like. So if you were wondering where this Flatmap and Flatmap methods come from, don't worry. That's part of Project Reactor, and this is here just to illustrate and to help how we would use that library, because to be honest, there is no reference implementation for reactive streams. There are a couple ones, like Akka Streams, RxJava, and Project Reactor, and these days we have seen also things like ZeroDeb. But we have to use one of these libraries to properly make use of reactive programming. Without, it is really a tough time to use publishers directly. So back to that example. In this example, we create a connection, and once this connection gets emitted, so it is ready to be used, we declare that we want to select values. So select value from test. We execute that statement, and then in another Flatmap step, which is basically saying as soon as we receive results, we start extracting results from there. So the by function is accepting row and metadata, and it is extracting the value column from the results. And effectively, I get a stream of these values as a result. If we start using prepared statements or parameterized statements, like this insert, then we have to use bind markers. And what we currently see here is the Postgres syntax. And Postgres uses dollar notation with indexes starting at 1. But don't worry, these bind things either accept the name or start at 0 index. So I think that's at least something which helps us to get rid of this one based index. And what happens here is that we bind the value 100 to the first parameter, the value 200 to the second parameter. Then we call add, so we are opting in for batching. And then we are binding another set of parameters and finally executing that statement. So we execute that statement with multiple parameter bindings, and the driver can figure out whether it sends two times that statement or whether it has an optimized method to do that execution in a single shot. Cool. That's simple so far. That's good. Let's go to transactions. And there we will see it's not going to be simple anymore. So this is by intent, but this is not to upset you folks, but this is rather a thing where we see this SPI isn't intended for end-user usage, but it is intended for client usage, and clients should take care of this transactional demarcation. Clients should be able to wrap whatever you try to do within a transactional scope and manage a transaction according to your rules. You can still do that manually, if you like, but we will end up with a similar pattern like we do in JDBC with this try-catch, finally try-catch, to make sure to commit the transaction, to roll back the transaction, and also propagate the error. So that's basically all this code expresses. So the API is verbose with the intent to enable a standard API for client library developers. And I think we need something which is standardized. Otherwise, we won't see really growth or adoption of asynchronous client libraries on top of an asynchronous or even reactive API to interact with databases. See, if there wouldn't have been something like JDBC, we wouldn't have JDBI, we wouldn't have MyBartis, we wouldn't have JPA, Juke, all these fantastic libraries and specifications that allow us to get around with a lot of developer productivity. And I think this is the most important part about our TwoDBC itself. Reactive is cool, and async and non-blocking is all cool, but we need a common language to enable client library authors to build on top of something which gives us efficiency and which gives us also developer productivity. And as an example, we started within the R2BC team to come up with a driver and also with a client implementation. And the client implementation is oriented along the lines of JDBI. So let me walk you quickly through that. So in this first slide, we basically see how we could imagine our client library could execute a simple select statement. So we no longer have this all wrapping with create a connection, and here's a connection factory and Flatmap, all that, but rather we express, okay, I want to execute a select operation, and I want to consume the results. And everything else is handled by the client itself. We get less verbose, we get less error prone, and we get only the operations that make sense in a particular context. Another example with this parameterized statement could look like that way. That we have a create update operation. The create update operation returns us something where I can express the multiple bindings and just execute that thing right away. And from my experience, in most times, I do not care how many rows were updated or inserted. I just care in most times that this thing was executed, whether successfully or with an error. But this completion and successful completion or error completion is the thing I'm interested in. Still, a client can offer multiple results and also offer consumption of generated keys. But yeah, like I said, I'm using a particular client because it gives me that what I need for my particular application. And if we throw now transactions in the entire picture, so Now pay attention what changes. Basically, we do not see much. So let me go back. So in the very first line, we have with handle is the entry method. With transactions, we have a in transaction method. And all this cluttering, all this transaction control is handled and encapsulated by my client library in a most sensible way that if there happens an exception, I get the exception result, the transaction is going to be rolled back, and I'm getting the outcome of the operation. I'm not cluttering my application anymore with any transactional control, although I still could. And in other frameworks where I could perhaps use annotations to demark transaction rules, transaction propagation rules, it would basically feel as I'm augmenting just what I'm doing with a transactional scope. So I'm getting less visibility on this infrastructure code that does begin, commit, rollback, all that, but rather I express just what I want to achieve with my application. So we took also a look on our TwoDBC from a Spring perspective. And what we see here is a functional way how to express my intent to access on data. So inspired from the web client, from Spring Webflux web client, we came up with the idea of the database client. The database client accepts a connection factory, and then I can express basically what I want to do. And here in this example, we do a simple select. We use parameter binding. And if we pay close attention to how parameters are expressed in that way, we will see we're using name parameters, which are much more convenient to use because I don't need to dig into database specifics. So I do not really care whether that's a Postgres, H2, MySQL, or SQL Server, but rather the client implementation is taking care of that for me. I'm getting portability out of that, and I'm getting a streamlined API that is just fluent. I'm binding a value to that parameter. I'm expressing that I want to map the outcome to that person class, and then I'm fetching that data. And in the end, I'm getting a flux of person or a publisher of person. So flux is an implementation of publisher. We not only get the database client with Spring Data R2DBC, but also the repository abstractions. So we can express a particular query, annotate that on a query method, and then execute the query method right away. So we get all that convenience that we are probably having today in an imperative world, also in the reactive world, with a slightly different approach, how we declare and think about return types. But basically, the thing that's going to happen here is the same what is happening in the imperative world. Instead of returning a list of customer, I'm getting a flux of customer with a really huge advantage that I do not need to think about paging anymore. I can just stream huge result sets without issuing multiple queries. And I'm just streaming all the data right away because I do not have to collect all the data upfront in lists and performing any translations, any mapping on top of that. So I was mentioning JDBC URLs earlier, and we also want to take a look at how this will look like in R2DBC. So connection URLs are an awesome way to configure the database endpoint. It's a very simple way because we just have a string, and the driver itself is going to take care of the resolution to resolve which host to go to and these kind of things. So we thought, let's put that into a central place and make this also a first-class citizen. So driver implementers just get structured data. They do not need to apply URL parsing anymore, but they get a configuration object, and then they can create a connection factory out of that. Or even in this example, I can say, hey, I want to talk with Postgres at that host, but please, R2DBC, please apply also pooling on top of that. And what is going to happen here is that we are creating a connection pool first, and then the connection pool is delegating the connection creation to the Postgres driver. And that's a very slick way to express just what I want to do without the driver vendors to do really much on that end. So what can we do today? 2 years ago, it started all with a, let's see what's possible. Let's see how we can explore the reactive space with SQL database connectivity. We announced last year at Spring 1 that we have something, and that we were happy with the outcome of our experiment, and that we want to follow down that path and make it more stable. So today I would consider R2DBC and also the driver implementations alpha quality. So please do not use it in production yet. Also not tomorrow. Maybe mid of the year, end of the year, something like that. But it is good enough for you to start on that end, to start playing with drivers, with the integrations, to see what features work well and what doesn't work, what's missing. And we are happy to get all that feedback from you. We have driver implementations for H2, for embedded databases, Microsoft SQL Server, Postgres. We have a community-contributed implementation for MySQL. So we have already 4 databases that we are supporting. And for such a young project, that's already a lot of things. You can do batching. You can convert between types. So like if you have a date with time in your database and you are interested only in the time part, you can ask for a local time. These kind of things. We support transactions, save points, all these things around isolation, and more things are to come. You can get R2DBC as artifact. So in fact, there is even a BOM, which encapsulates multiple components within a single release train. So you will get the driver SPI, driver versions, or pooling, R2DBC proxy, and a couple of more components if you import that BOM into your favorite tool. And currently, it is available as 7th milestone. So you do not need to remember that, because you will get later on access to the slides. But what I want to tell you is that there is a big and growing ecosystem around R2DBC. We have this specification documentation that states how R2DBC is supposed to work. We have the SPI itself, which is basically just 5 or 6 Java classes. We have various driver implementations. We have connection pooling. We have this R2DBC proxy that gives us insights. We have a community that starts adopting R2DBC from various ends. And we have 2 client implementations that are currently being worked on, which is Spring Data R2DBC and the R2DBC client itself. And let me explain a little bit on what R2DBC proxy itself is. So I think it was the second ticket in the R2DBC project itself, which said, this is cool, what you're doing, but you know what? In the JDBC world, when we try to look into what's happening in a system, when your system is active, when it is running, it's quite hard to figure out which queries are executed, how long they take, because there's no standard instrumentation way to look into drivers. So every APM vendor, everybody who wants to get metrics and tracing out of JDBC drivers has to find a very vendor-specific way to achieve exactly that. And the ticket we received was basically, yeah, how about metrics, tracing, observability? What can you do about that? And there is a contributor in San Francisco who already built data source proxy. So that's basically a proxy around a JDBC data source, which allows registration of interceptors. So as soon as you execute a statement or create a connection, you can notify that interceptor and report which host this was and how long the particular operation took, error rate, success rate, so these kind of things. And the very same person started then in his free time and building R2DBC proxy, which is the reactive variant of data source proxy. And we were really blasted by how this thing worked. We had a couple of demos with agent-based integrations, how you can really plug in that R2DBC proxy into your application without modifying your application code. And so we decided, yeah, that's exactly the answer we were looking for to get observability, monitoring, tracing. And so we promoted R2DBC proxy to a top-level R2DBC project itself. Now, R2DBC isn't the only way how to access databases without blocking or with introducing concurrency. So there are, in fact, multiple ways how you can achieve that already today. So there are communities around Vertex, communities, independent communities that are building database drivers. But the thing there is, each of these driver implementations has a vendor-specific API. So we have no common language across these drivers. And if you want to stay database independent, vendor independent, then you have to build a lot of orchestration around that particular driver to stay portable. Second thing that you can do today already is using JDBC with a thread pool under the hood. So there are actually two issues to that. So first, when we are talking about reactive systems, then we are talking about efficiency. Reduce the number of threads from 200 threads or 500 threads that we have today in a Tomcat back to the number of threads that we have as available as CPU cores, like 5, 10, 16, something like that. And if you are introducing a thread pool to offload blocking JDBC calls, then we are basically providing yet another thread pool, which is just there for the sole purpose of offloading that blocking work. So there is no magic tool today available that can turn blocking calls into non-blocking ones magically. I think in the future we will see things like Project Loom, but we aren't quite there yet. So we have to pay that price of threads when we are putting JDBC on a thread pool. That's one thing. But the other thing is, and this is even more drastical, so when we are talking about scalability and reactive, we aren't talking about jumps from hundreds to 200s of parallel connections. But we are talking about thousands, 10,000s, 100,000s of parallel requests. So although we have just a small thread pool, because you can't really spin up 10,000s of threads in your single JVM, otherwise I think bad things would happen. So you have to cope somehow with this overflow work. So if your small thread pool of, say, 10 threads is already busy, and then you get the 11th, 12th, 13th request, you need to do something about that. And the typical answer to that is put it on a queue. So you enqueue that work, and as soon as a thread is available again, then you start processing basically that work, right? So the thing is, there are two sorts of queue, unbounded and blocking queues. And if you have an unbounded queue and you get a lot of requests, then you basically pay with your memory for the price of queuing the work. So in the worst case, all of this queue is going to eat up your application memory, and you do not have any memory left for your application to do its work. So that's a bad choice. If we talk about a blocking queue, which is bounded typically, well, if this queue is full, then we get blocking behavior again. And that's exactly what we try to avoid. So that's not a good idea either. And to sum it up about JDBC on thread pools, that's not a good idea if you want to run it on scale. If you want to run it locally within tests, that's probably okay. But to run it at scale comes with severe risks. There's also another thing, which is an initiative from Oracle. So 3 years ago, Oracle announced an asynchronous database API. And there is some progress going on around ADBA, asynchronous database API. But the thing is, there is nothing available yet that we could use as developers to leverage that API. The only thing available are a couple of Mercurial commits. And so this thing is available as source code, but not as a jar. So that's one thing we have to cope with. Second thing is, reactive is pretty much about single element streaming. So we do not deal with a list of person, but rather as a stream of person. So basically with T and not with a list of T. The aim of ADBA is asynchronous processing. And asynchronous APIs typically communicate with futures. So what you would get typically from ADBA is a completable future from list of rows or from list of person. So you basically have to accumulate all that results until the very last chunk is received by your application, and then you can start processing. And this you have to pay with time and memory, because you have to await until all of that data is available, and you have to store all that data somewhere. And these are the things we do not really like about ADBA. And so that's not an option for us as well. Okay, now I will show you a couple of things which are going to happen in the future. So therefore we have this safe harbor statement. You don't need to read it until the end. It basically says everything I tell you now may or may not happen. Although for the most things we already have pull requests open. So one thing which is really missing in R2DBC currently is how we deal and think about large objects. So if you have a 2 GB image on your database, you don't really want to pull all that in your heap, because basically then your JVM is going to crash. But rather we want to establish a way how to consume that large objects in a heap and memory-friendly way, how to stream a sequence of characters, how to stream a sequence of byte buffers. So that's currently being worked on. I already mentioned support for MySQL. We are talking with IBM regarding DB2, because DB2 is a very strong database, yet we do not have any asynchronous means to access that. And this is something which is closed source, so we cannot just come up with an open protocol specification to implement that. We released connection pooling last week as open source artifact. Until now, it wasn't really publicly available. We are discussing with microprofile folks, with Juke, with MyBartis, with JDBI folks, how we can create an integration between these ecosystems. And the communities are starting to pick up on that idea, because they also see that there is demand to provide solutions to reactive use cases. So the initial goal, which was to influence ADBA, that didn't really work out in the long term. But on the other hand, we are not going to accept a bad ADBA specification. In that case, we are going to carry on with R2DBC and making it as good as possible, so that we can just provide means to reactively access SQL databases. And that being said, everybody of you is invited to join that initiative. Everything is open and available as open source, licensed on the very permissive Apache 2 license. We have a website at r2dbc.io. You can reach us over Twitter. All the code is available on GitHub. We have a mailing list. We have also weekly calls where we discuss current matters and the progress of the implementation. And really, everybody is invited to have a look on that, to play with R2DBC, to give us feedback, what you are missing. And by the way, one of these things where we were talking about modern APIs is we assumed nobody is using stored procedures. Exactly, and that was also a learning that we carried away, and we are considering an API that allows us to work with stored procedures and to consume all that outcome of stored procedures. But we are not quite there yet, and really everybody is invited here to contribute to a really good reactive specification. And that, having said, thanks for your attention. I think we have still a couple of minutes time to take some questions. And if you have questions, these folks will help you with microphones.